Let's see how the electrons are arranged around the atom. Okay, so see, consider this nucleus, this atom. Okay, so here, so this is the nucleus, and this is the here it is the nucleus, right? So it is proton plus neutron. So here two electrons are there. So this shell, I mean like the place where the two electrons it is revolving around the nucleus, we call it as orbit. Okay, something similar to the, I mean like our solar system. Now the second place, like this is the actually this is the lowest energy shell, lowest energy shell. So the two electrons it will be revolving around the nucleus. Okay, so here, okay, and in next shell there are 8 electrons. 1 2 3 4 5 6 7 8. Okay, so there are 8 electrons are there. Okay, so here in the first shell there are 2 electrons, and in the second shell there are 8 electrons. Okay, so there are 8 electrons, and in the third shell, of course, it can occupy, actually in the first shell we call it as K shell, so that is 2, L shell that is 8, and M shell, and like it is 18. So 18 electrons can be accommodated in the third shell. So if I arrange these shells in the increasing order of the energy, so the K shells it is the lowest, L it is again lowest, and M it is the again lowest, again highest. Okay, so I mean like once it is far from the nucleus, say this K shell it is close to the nucleus, this L shell it is even closer, I mean little bit far, M shell it is even farthest, I mean farthest. So the shell which is very far from the nucleus, it is having more energy. The shells which is very close to the nucleus, okay, and that is having lowest energy. So that means the K shell that is having less energy, and L shell it is having higher energy, and M shell it is having even more energy. Okay, and this is the case. And now these shells we call it as K shell, L shell, M shell. Okay, K shell it is having lowest energy, which is closer to the nucleus, and L shell it is even having lesser energy, sorry, higher energy. M shell it is the highest energy, and if there is one more shell beyond M, that is going to be even having more energy. Okay, so there are total 2 electrons are revolving around the K shell, there are 8 electrons revolving around the L shell, and there are total 18 electrons revolving around the M shell. So we will we will see how many how to know how many electrons can be accommodated in a shell. See, for example, K is the first shell. So if I consider K is n is equal to 1, so it is 2n square. That is going to be 2 into 1 square. So that is going to be 2. So and L it is the second one. So 2 into 2 square. So it is going to be 2 into 4. So this is going to be 8. Okay, and for M it is going to be 2 into 9. So it is going to be 18 electrons. So just you need to remember this particular formula, 2n square. Okay, so if there is one more shell after the K, L, M and N shell, if I am saying about K, L, M and N shell, it can accommodate, this is going to be 4, right? So 2 into 4 square, 2 into 16, so this is going to be 32 number of electrons. Okay, so this is something you need to know, like the shell which is very closer to the nucleus, it is having the lowest energy. Once we go from higher, I mean nucleus to far, this is going to, the energy of the electrons it is going to increase. Okay, and now the electron shells for the, we will see the electron shells for the first 20 elements. Yeah, so you saw, right? Okay, so one thing is we will see the second period. I will show one more time. The lithium it is having So three electrons, and for for three protons also. Better I will write proton number. And for beryllium it is four proton, or like it is having three electron and four electron. Okay, and boron it is having five protons and five electrons, right? Okay. So this is something you need to know: lithium, beryllium, boron, and then subsequently carbon. It is having six electron. Carbon it is having six protons and six electrons, and nitrogen it is having seven protons and seven electrons. Okay. So when we go from one side to next side, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Okay, number of protons it is just increasing by one, right? 3, 4, 5, 6, 7. Then eighth one is oxygen, ninth one is fluorine, and tenth one is neon. Okay, so this is something you need to know from rising from one to next one. Just one proton will be increasing. So if it is next to nitrogen it is oxygen, so that is having 8 protons are there. Fluorine it is 9 protons, and neon it is 10 protons. Okay, so this is something you need to know, like so, and same way the number of electrons also it is increasing from 3, 4, 5, 6, 7, 8 and 9 and 10 electrons. Okay, see the periodic table, and you will see some trend. See, for example, you can see the second group. Yeah, not second group, I mean second period. Okay, see it again. Now, what are the elements in the second group? See, there are some trend it follows in the second group. For example, lithium. Okay, so lithium got atomic number 3. So, okay, so only one electron, right? And then again lithium, beryllium, 2 electron. Then total 2 plus 2 electrons. So total again there are 2 shells, right? Lithium, beryllium, boron. 2. Then actually it got electronic configuration 2, 3. Here it is 2, 2. Here it is 2, 1. Lithium, beryllium, boron. Then actually what is the next element? And it is carbon. So 2, 1, 2, 3, again 4. So it is 2, 4. So it is, you can see there is again 2 shells, right? So the elements you can see, the elements which is in the same period, it is having same number of shells. Okay, so every period, if it is same number of, and again you can see the next element, next to carbon, it is nitrogen. So it is nitrogen is having atom number 7. So it is so the first shell it is having 2 electrons, and the second one is having 5 electrons. Okay, so this is the case. Now, one thing you need to know, next one also, I mean after nitrogen it is oxygen, that is also having like it is having same number of shells, I mean 2 shells. Fluorine also having 2 shells, neon also having 2 shells, right? Now if you see the same group, okay, and lithium, sodium, potassium, rubidium and cesium. So here it is 2, 1. So these elements are belong to the same group. Let's see the trend follows in the same group. So here atomic number 11, 2, 8, 1. So here atomic number 19, so 2, 8, 8, 1. So the same way, here also the outermost electron going to be 1. Here also outermost electron going to be 1. 1, 1, 1. So the elements in the same group that follows same number of electrons in the outermost shell or valence shell. Okay, and here you need to know the like these elements which is in the same group, that is going to show the same, I mean like the same type of reactivity, same type of chemical reactivity it follows. Okay, and we can say like lithium it react with the water. Okay, it releases hydrogen. Same way for sodium, potassium, rubidium also. And sodium, for example, if you put a sodium into water, it releases hydrogen. Potassium into water also, it releases hydrogen. In fact, So let's see how that reaction is happening. One real fact you need to know that number of electrons in the valence shell, that is responsible for responsible for uh, the release of hydrogen, that is responsible for release of hydrogen, and number of electrons in the valence shell, that determines the chemical reactivity. How an element react, it is determined by number of electrons in the valence shell. Okay, so this also you have to know. Yeah, there are certain patterns in the periodic table. See, like periodic table, though it looks, the elements are arranged in some order, like on the basis of increasing order of atomic number. It is not, that simple. Yeah, even though it is arranged in the order of atomic number, the periodic table, you can say it is one of the most fascinating discoveries in the world of chemistry, because no research in chemistry shall happen without the assistance of periodic table. And every day the chemists and scientists, they will be exploiting the functionalities of periodic table. See, for example, the periodic table, it tells many information about an element. If you come to know, if you happen to know that a element is present in a particular group, particular place in a periodic table, you can say many information. For example, I will start from, see, the periodic table, the 13th group. Okay, I will start from the 13th group. Yeah, this is the periodic table, right? Actually, so here it is. Here it is. This is somehow the periodic table will be looking. So here it is S block element. So group 1 to 2, and here group 3 to 10. Here group no, not 3 to 10, 3 to 12. So here it is 13 to 18. Okay, here actually F block elements are there, and here it is S block elements, here it is a D block elements, and here it is P block elements. So what I am trying to say is, see, let's take the example of 13th group. So in 13th group, the elements present in the 13th group are, so boron, aluminium, this is 13th group, right? Gallium, indium, thallium. Okay. Suppose I am going to take one element, let it be aluminium. So you are aware that is in the 13th group, and if you are checking the period, it is in the third period. In first period, as you are aware, only two elements are there, hydrogen and helium. Second period, there is lithium. If I count from here, lithium, beryllium, boron, and then carbon, nitrogen, oxygen, fluorine, and neon. Okay, so this is the nature. Anyway, so this aluminium utilized in the 13th period. Let's see what information I can find. 13th period and 13th group and the 3rd period. So since it is present in the 13th group, so you can split in this way, 10 plus 3. So 3 valence electrons will be there. Okay, and if I write the electronic configuration, it comes 2, 8, 3. And now, how I am able to write this electronic configuration? Since it is in the, you can see the period. Since it is in the third period, it is supposed to contain 3 shells. So the period number, in which period it is located, it tells you how many number of shells are present in an atom. If it is present in a 3rd period, that means it contains 3 shells. If it is present in the 4th period, that means it contains 4 shells. If it is present in the 5th period, it contains 5 shells. Okay. Since it is in the 3rd period, and you can see, so this is K, L, M. Okay. So K, L, and M. So 3 electrons are present in the outermost shell. Okay. And since it is in the 13th group, yeah, you can say that 3. If I write electron configuration, it is once again I am writing 2, 8, 3, right? So 3 valence electrons are present in the outermost shell. Outermost shell. I mean, like your group number tells you how many electrons are present in an outermost shell. If I take another example, lithium. Lithium actually it is in the first group. So its lithium atomic number is 3. So it is 2, 1. So only one electron is present in the outermost shell, right? So if I take the example of carbon it is atomic number is 6. So it is 2, 8, 4. Sorry, 2, 4. So carbon it is in the 14th group. So that means it got 4 electrons in the outermost shell. If it is in the 15th group, that means 5 electrons will be there in the outermost shell. If it is in the 16th group, it is going to have 6 electrons in the outermost shell. Okay, so which group it belongs to tell you how many valence electrons are present in that, and which period tells you how many shells are present. For example, take the example of carbon. It is in the second carbon. Actually, it is in the 14th group, and second period. So immediately you can say it got 4 valence electrons and it got 2 shells because it is in the second period. So if I write the carbon, so it is going to have 2 electrons and 1, 2, 3, 4. So this is the electron configuration of carbon. Okay. Okay. Yeah, group number 0. See, in periodic table, you see the periodic table now. Where is the position of group number 0? Yeah, it is in the left, right end, right? Actually, if you see the periodic table, yeah, it is in the 18th group. Elements are called group number 0. So these elements are a little bit peculiar. If you happen to see, yeah, you know, you can see helium, yeah, neon, then actually which is the element? Neon and argon, krypton and xenon. So these are the elements. So helium got, so you know the number of shells, right? K, L, M and N. Okay, so helium, if I write the electronic configuration this side, helium it is having 2 electrons. Neon it is having 2, 8 electrons. Argon it is having 2, 8 electrons. Okay, and subsequently if you happen to see its outermost shell, it is always getting filled. So here I can write for simply, I can write argon. Okay, so 8. Okay, so here also outermost shell for xenon also outermost shell it is getting filled. So this element is called 0 group element. So do you know why it is called 0 group elements? Because it is highly unreactive elements. It doesn't react. You know the reason why we are filling helium or like yeah, in our bulb binder, I mean like a fluorescent bulb, we used to fill in neon. Okay, neon or argon normally. The reason is actually these elements are very unreactive. It doesn't react with any other elements. So due to that, it protect and it give a very inert environment into the fluorescent condition, fluorescent medium. Okay. Now you may tend to ask actually for helium, yeah, only there is 2 electrons. Okay, all others 8 electrons. Yeah, even then helium is also not going to be reactive because in the K shell, what is the maximum capacity? It is 2 electrons, right? So helium is also completely filled element. It doesn't react with anything. Okay, so this is something you need to know. And one more thing is how an element is reacting. It depends on whether it has unpaired electrons or like whether it is having empty shells. For example, you know lithium. So for lithium, so it is 2, 1. So it has only 1 electrons in the outermost shell. So it got a tendency, you know, either to release this 1 electron or like accept 1 electron. So okay, maximum it release 1 electron, so that you know lithium, if it is releasing 1 electron, it changes into lithium plus and release 1 electron. So from it convert from 2, 1 to 2, so that you know its outermost shell is stable and there is completely I mean like a K shell, it is having only one electron, right? Actually, sorry, only two electrons it can accommodate, and it is a maximum capacity is getting filled. So this is the tendency, or like if you take any element, you know, it either got a tendency to accept electrons or to release electrons, so that that element remains stable. It element acts as a very stable element. So the same situation is not in the case of these inert gas elements. I mean this is zero group elements. It is 18th group, in fact, also called zero group. Zeroth group. Okay. So these elements doesn't react due to the, because it doesn't need to release electron also, it doesn't need to accept electrons also, because you see already the outermost electrons are completely filled, right? So it doesn't need to accept, doesn't need to release. So these elements are highly unreactive due to the very stable electronic configuration. If you happen to see the elements after calcium, for example, calcium, it got atomic number, calcium it is 20th element, right? So 2882. This is the electronic configuration of calcium. So this is K shell, L shell, M shell and N shell. It got to 4 shells. Okay. So that means it is in the 4th period. Since it is having 2 outermost electrons, it is in the 2nd group. So the elements after calcium, it is not easy to, a little bit it's complicated in electronic configuration. Still then you will be able to tell, like if you know that element lies in which period and which group, you will be able to tell how many shells are there, and you will be approximately, you will be able to write the electronic configuration also. For example, hereafter you can easily write many of the electronic configurations. If I take an example, let it be in your textbook, the example given is rubidium. So rubidium, its atomic number is 37. That means it is the 37th element. So from that you can say the number of protons in rubidium, it is 37. Since it is a neutral atom, number of electrons also going to be 37. Okay. So this information you can write. Now, if you are able to, if you are able to know its a group and a period, so then still more further information, you can easily write its electronic configuration. So rubidium, it is in the 5th period. Okay, and actually lithium, sodium, potassium, rubidium. Yeah, rubidium. So it is in the 1st group. Now we can write, actually since it is in the 5th period, so we can write how many number of shells, right? K, L, M, N, O. 1, 3, 4, 5, right? So in K shell the maximum capacity is 2, and L shell the maximum capacity is 8. Of course, in the outermost shell, since it is in the 1st group, we can easily write O, it is going to have only 1 electron. And M shell, it can maximum accommodate 18 electrons. So we will write 18. Okay. Now how many is totally filled? So 18 plus 2, it is 20. So 28 and 29. So remaining actually it is supposed to be 8. Okay. Now we will check, right? So 8 plus 2, it is 10. So again 10, 28, 29 and 37, right? 37. So this is the way easily you can write, actually, like once you know the period. And if you take any other element other than rubidium, other than cesium, or other than whatever the element you take, if you know the period, I mean like a group number and which period it belongs to, you are able to write and you are able to write its a proper electronic configuration. Okay.